In this video, I'll show how to use the derivatives of trigonometric functions to find the derivatives of some larger functions. So first, let's list the derivatives of the 6 basic trigonometric functions. And that is, if I have functions f of x, then I'll put a corresponding f prime of x, the derivatives of those functions. So I'll list first sine of x, cosine of x, and tangent of x. And the corresponding derivatives of those, the derivative of sine of x is just cosine of x. There's some really neat math behind that, but for our purposes, really it's okay to just memorize that the derivative of sine of x is just cosine of x. The derivative of cosine of x, it turns out, is negative sine of x. Again, some really neat math behind why that is, but we can just use it. So we don't have to make the hammer, we'll just use the hammer today. Now, the derivative of tangent of x could be found using the quotient rule if you just know these, because tangent of x equals sine of x over cosine of x, and you can apply the quotient rule. What you would get in the end after you simplify would be secant squared of x. And again, for our purposes, it's okay to just memorize that. As much as you may have heard me say in other videos that I like to memorize very little and understand a lot, I'll have to concede that for these, the derivatives of trigonometric functions, it turns out to be a little bit faster, a little bit easier to just memorize them. And with a lot of practice, or even just a little bit of practice, you'll get to memorizing these. Now, to the reciprocal functions, that is 1 over sine of x is cosecant x. So the derivative of cosecant x is negative cosecant x cotangent x. And the derivative of secant x, again, secant x is 1 over cosine of x. The derivative of secant x is secant of x tangent of x. So you see a little pattern here, a similarity, that with cosecant and secant, you're leading off with the function, the original function. There's a negative in front of the cosecant, and then after that is the co. So with cosecant, you get a cotangent, and with a secant, you get just the regular tangent. Just little tips to help you memorize these. If we have cotangent, which is just cosine of x over sine of x, you actually end up with not secant squared, but negative cosecant squared of x. So just one more thing, or a couple more things to help you memorize these. Some people like to think of all of the cosine, cosecant, and cotangent of x all have the negative sign in the derivative. So that's one more thing to help you memorize these derivatives of these trigonometric functions. So let's get to it. Let's use the hammer, as I say. We've just laid out the rules. So if I have h of x equals sine of x plus cosine of x, we're going to find the derivative of that. And so the derivative, that's h prime of x. Well, the derivative of sine of x we know is cosine of x. So I'll write cosine of x. And the derivative of cosine of x is negative sine x. So I'll write negative sine of x. And that's it. That was a fast one. All right, the next one, g of x equals tangent of x multiplied by cosecant of x. And if you're thinking the product rule, that's good. I applaud you for thinking that we can use the product rule, and that's okay to do here. However, I'm going to simplify this first, because if you can simplify a function first, actually that's usually an easier way to do it. Now, later on in calculus, you might be doing some things where you'll want to expand things and not simplify it. It turns out to make things, the antiderivative, easier, but for now, we're going to simplify when we can. Okay, tangent of x is sine of x over cosine of x. cosecant of x is 1 over sine of x. So check this out. Sine of x cancels or divides out to 1. So we're left with 1 over cosine of x. I'm going to make a leap here. I'm not going to rewrite 1 over cosine of x. I am going to write g of x equals secant of x. All right, because 1 over cosine of x is secant of x. Now on to the derivative. I'm going to change colors. Let's go to an orange. No, we've used orange. Let's go to pink. All right, g prime of x, the derivative of that. Well, the derivative of secant of x is secant x tangent x. So we'll just write that out. Secant x tangent x. And by the way, if you used the product rule on the function as it were written, that would have been fine. You would get some version of this. You might remember from trigonometry that a lot of times trigonometric functions can be rewritten in other ways. So anyway, this is a good way. You simplify it first and then take the derivative, and that was pretty fast.